Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Oabutiwa Sos Ukobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 6 on Newton's law of universal gravitation. And it says the gravitational force on a probe called Curiosity on the surface of Mars is 3,338 newtons. The radius of Mars is 3,390 kilometers, and the mass of the planet is 6.39 times 10 to the exponent of 23 kg. So we are given the mass of the planet. We are given the force that the mass exerts on the probe, and then we are given the radius of the mass, which is 3,390 kilometers. 6.1 says, state Newton's law of universal gravitation in words. So quickly to that, we say Newton's law of universal gravitation states that every body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So that's how they expect you to define that for a total of 2 marks. Then 6.2 now says calculate the mass of the probe. So we know the formula that we should use for 6.2 is the one that goes F is equals to G M1 M2 over R squared. So we are given the radius. We're gonna use that formula there. Now, the force that we are given, we can see it's here, 3,338 newtons. And then we know that our G here is the gravitational constant, universal gravitational constant. Then that's 6.67 times 10 to the exponent of negative 11. Our mass 1, let's take it as the mass of a planet mass, which is 6.39 times 10 to the exponent of 23. Then obviously we do not have the mass of the probe, right? So that's what we are looking for. But we do have the radius of the planet mass, which we are given in kilometers. We know every time we are given the distance in kilometers, we should convert that distance to meters. So how do we convert kilometers to meters? We know that we multiply by 1,000. So you can multiply by 10 to the exponent of 3, which is the same as multiplying by 1,000. So that means now this distance, we're going to write it as 3,390 multiplied by 10 to the exponent of 3, and then we square that. Remember, we have R square, it's the square of the distance. Now, if you want to calculate this without having to just go further with your maths, you can just cut down all these steps by just taking this one, multiply, cross multiply with that one. Remember, this is over 1. So we can take the whole R square multiplied with the force here, then take whatever that we have here on the numerator, then divide throughout by that. So that's 3,338 multiplied by 3,390 times 10 to the exponent of 3, and then we say square. And then we take the numerator, divide by the numerator there, 6.67 times 10 to the exponent of negative 11, and then we have 6.39 times 10 to the exponent of 23. Now at this point, you can just grab your calculator, punch all this into your calculator, then just like that, you'll have your mass. So remember, we do not really care much about your maths when it comes to physical sciences. So always make sure that you cut down your steps as much as possible, right? Then all we care about is that you'll have written your formula, substituted into the formula, and then did whatever to get the mass there. Then that's how you could have got your 4 marks. Then for 6.2, they say calculate the weight of the probe. So how do we calculate the weight of the probe? We know the formula is W is equals to mass times the gravitational acceleration of the Earth. Then we know that's M. We have already calculated the mass. It's 900 0.03 kg, then multiply that by the gravitational acceleration on Earth, which is 9.8. Then if we multiply the two, we find out that the mass of the probe on Earth will be significantly larger than the weight of the probe will be significantly larger than the weight of the probe when it is on planet Earth, right? So that's what we have there, 8,820.29 newtons, right?